Nvidia is not just selling shovels in the AI gold rush. It may be collecting a toll on almost every road into the mine. And that is the part many people still miss. Most conversations about Nvidia sound like stock market arguments. Is it expensive? Is it overhyped? Can it keep growing? Those are fair questions. But they are also the smaller questions. The bigger question is how one company became the default infrastructure layer for the most important technology build-out of the decade. Not the only chip maker, not the only AI company, not the only player in the data center. The default. If a startup wants to train a large AI model, there is a good chance it wants Nvidia GPUs. If a cloud provider wants to rent AI computing power, there is a good chance customers are asking for Nvidia. If a giant tech company wants to build an AI data center, Nvidia is probably somewhere in the blueprint. And if a developer wants to make high-performance AI software run fast, the path of least resistance usually leads back to Nvidia's ecosystem. That is not normal market power. That is infrastructure power, the kind that hides in plain sight. For years, Nvidia was known by regular people as the company that made graphics cards. Gamers knew the brand. Crypto miners knew the brand. PC builders knew the brand. But outside that world, Nvidia did not feel like a company sitting near the center of the global economy. Then AI changed the map. Suddenly, the same type of chip that made video games look smoother became the engine behind large language models. The reason is simple enough. Traditional computer processors are very good at doing complicated tasks one after another. GPUs are very good at doing huge numbers of simpler calculations at the same time. And modern AI is basically a mountain of math, not a normal mountain. A mountain so large that the only way through it is to split the work across thousands, then tens of thousands, and eventually hundreds of thousands of chips. Nvidia was ready for that moment because it had spent years building for a market that did not fully exist yet. The company had the chips. It had the software. It had the developer tools. It had the relationships with cloud companies. It had the networking technology to connect chips inside giant data centers. And most importantly, it had become familiar. In technology, familiarity is a weapon. Engineers do not always choose the theoretically cheapest option. They choose the option that works, the option their team already understands, the option that has documentation, libraries, examples, community support, and fewer surprises at 3 in the morning. That is where Nvidia's real power begins. Because the AI economy does not just run on chips. It runs on confidence. Confidence that the hardware will arrive. Confidence that the software will run. Confidence that a model trained in one environment can scale in another. Confidence that the next generation of products will be stronger than the last. And confidence that if something breaks, the entire ecosystem has probably already seen the problem before. That is very hard to copy. A competitor can make a fast chip. A cloud company can design a custom accelerator. A startup can promise a cheaper inference engine. But recreating the habit of an entire industry is different. Nvidia did not just win a product cycle. It trained the market where to look first. And once you understand that, the AI boom starts to look less like a straight line from innovation to adoption. It starts to look like a loop. AI startups raise money because investors believe AI will transform industries. Those startups spend heavily on cloud computing. Cloud providers buy more AI servers to meet demand. Hyperscalers build larger data centers because they do not want to fall behind. Enterprises begin testing AI tools and private models. Governments and research labs want sovereign AI capacity. Infrastructure companies build the power, cooling, networking, and facilities around it. And through all of that movement, a surprising amount of the money ends up flowing toward Nvidia. Not all of it, but enough to make Nvidia look less like a supplier and more like the cash register of the AI build-out. This is why the company can be underestimated, even when everyone is already talking about it. People see the valuation. They see the headlines. They see the massive quarterly numbers. But they still think in old categories. Chip company, semiconductor stock, GPU maker. Nvidia is becoming something stranger than that. It is becoming the company that AI companies must plan around. And that is a very different kind of power. The easiest way to misunderstand Nvidia is to think the moat is just the GPU. The chip matters. It matters a lot. Nvidia's best GPUs are incredibly difficult to design, manufacture, package, deliver, cool, and operate at scale. But the chip is only the most visible part of the machine. The real machine is the stack. At the bottom, there is silicon. Above that, there are boards, servers, and systems. Around those systems, there is high-speed networking. Above that, there is CUDA. Above CUDA, there are libraries, tools, frameworks, optimized models, developer communities, and enterprise platforms. And sitting on top of all of it is one simple promise. Build here, and your AI workload has a better chance of working. CUDA is one of the most important parts of this story because it turned Nvidia GPUs from hardware into a programming platform. It gave developers a way to use GPUs for more than graphics. Scientists used it. Researchers used it. Machine learning engineers used it. Universities taught it. Frameworks optimized for it. Companies hired people who knew it. Year after year, a quiet form of lock-in formed. Not the obvious kind where a customer is trapped by a contract. The deeper kind where the whole organization becomes fluent in one language. Once your team has written code for Nvidia hardware, built workflows around Nvidia tools, tested models on Nvidia systems, and hired engineers who know Nvidia's ecosystem, switching is no longer just a purchasing decision. It becomes an engineering project. It becomes a risk. It becomes a delay. And in the AI race, delays are expensive. This is why cheaper chip is not always enough. A rival product can look attractive in a spreadsheet. It can offer better pricing. It can perform well on certain benchmarks. It can make sense for a specific workload. But the buyer still has to ask a painful question. What happens when we try to move everything? Will our existing models run? Will our engineers need to rewrite code? Will our tools behave the same way? Will the cloud instances be available? Will the next model architecture be supported? Will we get blamed if the project falls behind? Nvidia benefits from all of those questions. The more complex AI becomes, the more valuable the default becomes. And Nvidia has worked very hard to become the default. That is why its data center business is not just about selling individual chips. Nvidia increasingly sells systems, racks, networking, software, reference architectures, full data center scale platforms designed for training, inference, simulation, robotics, and enterprise AI. This matters because the AI data center is not just a warehouse filled with GPUs. It is a giant machine. Thousands of chips have to act like one coordinated computer. They need to move data quickly. They need memory bandwidth. They need low latency networking. They need cooling. They need software that can schedule work across the system. They need reliability, because downtime at this scale is not a minor inconvenience. It is a financial event. This is where Nvidia's acquisition of Mellanox becomes more important than many people realized at the time. Networking used to sound like the boring part. But in AI data centers, the network can decide whether expensive GPUs are fully used or sitting idle while waiting for data. A billion-dollar cluster can be weakened by bottlenecks. So Nvidia's control over high-speed networking gives it another layer of influence. It is not only selling the engines, it is selling the roads between the engines. And then there is the cloud. Nvidia has become deeply tied to the major cloud providers because AI companies often do not buy chips directly. They rent compute. They use AWS, Microsoft Azure, Google Cloud, Oracle Cloud, CoreWeave, and specialized AI cloud providers. Those cloud companies then buy or deploy Nvidia systems because customers want access to Nvidia capacity. The cloud provider wants the startup. The startup wants the GPU. The GPU pulls demand back toward Nvidia. That is the loop again. Customer demand creates cloud demand. Cloud demand creates Nvidia demand. Nvidia availability attracts more customers. It becomes self-reinforcing. This is why Nvidia's power is not only technical, it is psychological. When a founder raises a large AI funding round, investors expect speed. When a cloud provider announces an AI region, enterprise customers expect availability. When a Fortune 500 company launches an AI initiative, executives want the safest supplier name in the room. In many rooms, that name is Nvidia. Not because every Nvidia product is perfect, not because no alternative exists, but because Nvidia has become the answer that requires the least explanation. The AI boom has created a strange money loop. On the surface, it looks like thousands of different companies are building thousands of different AI businesses. Model labs, cloud platforms, enterprise software companies, data center developers, energy providers, networking suppliers, consulting firms, chip designers, startups with names that sound like they were generated 5 minutes before the funding announcement. But underneath the noise, a lot of these businesses depend on the same scarce resource: compute. AI companies need compute to train models. They need compute to serve users. They need compute to experiment. They need compute to reduce latency. They need compute to make their products feel faster, smarter, and more reliable. And the more ambitious the promise, the more compute they need. This creates a financial pattern that is easy to miss. An AI startup raises money from venture capital funds. Some of that money goes to engineers. Some goes to offices, marketing, legal work, and all the normal costs of building a company. But a very large share goes to cloud bills. Those cloud bills help justify cloud companies buying more AI infrastructure. The cloud companies then spend billions on servers, GPUs, networking, storage, power, and data center capacity. The infrastructure providers expand. Investors fund more specialized AI cloud companies. Big tech companies announce larger capital spending plans because none of them wants to be the one that underbuilt. Enterprises see the cloud capacity and start testing their own AI systems. More usage creates more demand. And again, a meaningful portion of the money flows back toward Nvidia. This is the hidden business model of the AI boom. Not hidden because it is secret. Hidden because it sits behind everyone else's story. When a chatbot goes viral, Nvidia is there. When a cloud provider sells AI instances, Nvidia is there. When a startup promises to automate customer service, Nvidia may be there. When a company trains a robotics model, Nvidia may be there. When a government wants national AI infrastructure, Nvidia may be there. The brand on the product may belong to someone else, but the bill of materials often tells a different story. This is one reason Nvidia's margins have shocked people. In a normal hardware business, competition eventually crushes profits. Buyers compare suppliers. Products become interchangeable. Price becomes the weapon. Margins fall. But Nvidia has not behaved like a normal hardware company. Because Nvidia is selling into a market where the product can be the difference between being first and being irrelevant. For an AI lab, the cost of falling behind can be much larger than the cost of expensive chips. For a cloud provider, not having enough Nvidia capacity can mean losing the fastest growing customers. For an enterprise, choosing the unproven path can create career risk for the person who approved it. Nvidia sells performance, but it also sells permission. Permission to move fast. Permission to tell investors the company has serious infrastructure. permission to tell customers the system is built on the industry standard. This is why the comparison to old monopolies is tempting, but imperfect. Nvidia does not control AI the way a railroad controlled a physical route. It does not own every model. It does not own every cloud. It does not own every data center. It does not own the entire semiconductor supply chain. But it sits at a point where many routes converge, and bottlenecks create power. The supply chain side makes this even more important. Nvidia does not manufacture its own most advanced chips. It relies on partners like TSMC for leading-edge manufacturing and on advanced packaging capacity that is difficult to expand quickly. It depends on high-bandwidth memory suppliers. It works with server makers, contract manufacturers, cloud providers, and data center builders. That sounds like vulnerability. And it is. But it is also influence. When your product is the thing everyone is trying to get, the supply chain starts organizing around you. Partners prioritize capacity. Customers plan around delivery schedules. Competitors benchmark against your roadmap. Investors listen to your demand signals as if they are reading the weather forecast for the entire AI economy. That is the strange position Nvidia now occupies. It is not simply participating in the AI cycle. It is helping set the rhythm of the cycle. When Nvidia launches a new architecture, cloud roadmaps change. When Nvidia increases supply, AI capacity changes. When Nvidia talks about inference, enterprise AI, robotics, or sovereign AI, entire markets begin paying attention. This does not mean Nvidia is invincible. It means the company has moved upstream. It is no longer just asking, who wants to buy our chip? It is shaping the question everyone else has to answer. How much AI infrastructure can we afford to build, and how quickly can we get it? But there are real risks. Nvidia's position is powerful, but powerful does not mean untouchable. The first risk is competition. AMD wants a larger share of the AI accelerator market. Google has its own TPUs. Amazon has Trainium and Inferentia. Microsoft, Meta, OpenAI, and other large customers have strong incentives to reduce dependence on a single supplier. Startups are building specialized chips for inference. And in technology, no lead lasts forever simply because it was impressive. The second risk is customer concentration. A huge share of AI infrastructure spending comes from a relatively small group of hyperscalers, cloud providers, model labs, and large enterprises. If those buyers slow their spending, digest capacity, or push harder on price, Nvidia would feel it. The company may be central to AI, but it is still exposed to the buying cycles of its largest customers. The third risk is geopolitics. Export restrictions can limit what Nvidia can sell into important markets. Rules can change quickly. Products designed for one regulation can become restricted under the next. And when AI chips become strategic assets, business decisions start getting pulled into national security debates. That is not a small footnote. It can affect inventory. It can affect demand. It can affect supply chains. It can create space for local competitors. And it can make long-term planning much harder. The fourth risk is expectations. Nvidia has grown so quickly that the market now expects extraordinary execution. Great results can be treated as normal. Normal results can be treated as disappointment. And any sign that AI infrastructure spending is slowing can trigger a much larger reaction than the business itself might justify. This is where investing psychology becomes part of the story. Once a company becomes the symbol of a boom, people stop judging it only as a company. They judge it as a referendum on the entire trend. If Nvidia rises, people say AI is still alive. If Nvidia falls, people ask whether the AI bubble is popping. That is a heavy role for any business to carry. And yet, even after listing all of those risks, the central point remains. Nvidia's strategic position may be stronger than many people realize, because the biggest threat to Nvidia is not someone making a chip that is good in isolation. The bigger challenge is building a complete alternative path. Hardware that works, software that developers trust, cloud access that customers can rent, networking that scales, tools that reduce friction, supply chains that deliver volume, enterprise products that reassure CIOs, a roadmap that convinces customers to wait for the next generation instead of leaving the ecosystem. That is a lot to replicate. Nvidia's moat is not one wall. It is a maze. Some customers will use alternatives. Some workloads will move to custom chips. Some inference tasks will become cheaper and more specialized. Some companies will deliberately avoid giving Nvidia too much power. That is already happening. But the existence of alternatives does not automatically destroy the default. The default can lose pieces and still remain the center. It can become less dominant in one area while growing in another. It can face pressure in training while expanding in inference. It can face custom silicon from hyperscalers while selling networking systems and software into the same ecosystem. This is the part that makes Nvidia unusual. Competitors are not always attacking Nvidia from outside the AI economy. Many are still building inside a world Nvidia helped create. Even when customers want leverage against Nvidia, they often need Nvidia capacity while they build that leverage. That is a very comfortable kind of discomfort for Nvidia. Everyone wants options, but almost everyone also wants access. And access is where toll booths live. The next phase of AI may not look exactly like the last one. Training massive models may become more efficient. Inference may become the bigger battleground. Enterprises may demand cheaper systems. Governments may want domestic infrastructure. Energy and cooling may become harder constraints. Capital spending may rise and fall in waves. But in each version of that future, the same question keeps appearing. Who provides the infrastructure that makes AI usable at scale? Right now, Nvidia has one of the strongest answers. Not because it owns every piece. Not because no one can challenge it. Not because the stock can only go up. But because it sits across the full stack at the exact moment the world is trying to rebuild computing around AI. That is why calling Nvidia a chip company feels increasingly incomplete. A chip company sells components. Nvidia sells the PICs, the maps, the roads, the training manuals, and in many cases, the fastest route into the mine. The AI economy may produce many winners. Some will build models. Some will build apps. Some will build data centers. Some will provide power, cooling, memory, servers, and cloud services. But before many of them can even compete, they need to pass through the infrastructure layer. And that is where Nvidia waits. Nvidia may be called a chip company, but in the AI economy, it looks more like the toll booth everyone has to pass through.